Welcome to qnawire.
All right, guys, we're doing problem 20 of chapter 9 in Chemistry Central Science. So, which of the following molecules can you confidently predict the bond angles about the central atom? And for which would you be a bit uncertain? So, they want to explain each case. First one, we're going to do H2S. So, H2S has two non-bonded electron domains around the sulfur atom. Hence, there'd be deviation from ideal tetrahedral geometry. So this would be our electron domain geometry would be tetrahedral because we have two bonding domains and two non-bonding domains. So if we have four electron domains around our central atom, that means our structure is tetrahedral. As however, as as however, when we look at remember when we think about the electron domains, like these are not just sitting around, these have a defined area in space. You can think of them as like pseudobonds. They're electron domains, but are attached to any atom. So the reason why you wouldn't have ideal tetrahedral geometry is that you wouldn't have atoms causing the same degree of, I guess you could say repulsion. Your electron domains don't take up the same amount of space as they would if you have atoms. So that's going to affect the bond angle slightly. That's the reason tetrahedral atoms don't have the same structure as bent atoms. Sorry, tetrahedral molecules don't have the same bond angles as bent molecules. That the presence of those non-bonding domains slightly affects the angle, because in the absence of these domains, you would form a linear atom at 180 degrees. But the fact that you have these domains, that actually will create a tetrahedral structure and affect the angle, but the HSH angle. So now we're going to part B. Boron chloride is trigonal planar, and there are three electron domains around the central atom, and all the domains are identical. So I can be very confident that all of these angles are at 120 degrees. The electron domain structure geometry is same as molecular geometry, so it's all going to be trigonal planar. S. So for CH3EI, it's tetrahedral, but all the bond angles are not identical because we have CH bonds, but we also have CI bonds. The iodine atom will be larger in size and will occupy more space. And as a result, the CH bonds will come closer to minimize the bond angle. So I can't be as so I can't be certain about what the bond angle will exactly be. And so let me just write saying what I'm certain and not certain of. Uncertain is going to be X. Certain is going to be check mark. All right, so now part D, CBr4. So CBr is tetrahedral and the bond angle is 109.5 degrees. Because if you're surrounded by four electron domains, remember, that gives you electron domain geometry of tetrahedral, and in this case, if there's no lone pairs, that gives you a molecular geometry of being tetrahedral as well. So I can be confident that these all have 109.5 degree bond angles because this is a perfectly tetrahedral molecule. Now, tellurium bromide has a trigonal pyramidal electron domain with a non-bonded pair of electrons occupying the equatorial plane. So let's draw this electron domain here, and let's draw the trigonal bipyramidal, like what it would actually look like. us. So remember, in trigonal bipyramidal, these three are in the same plane with each other. Let me kind of just draw this. So like they're forming this triangular plane. Well, this bromine and this bromine are above and below our tellurium respectively. So the fact that we have a lone pair that's going to be in the equatorial plane, this triangle right here. So since it's in that plane, like I said before, the fact even though you do have electron density with a lone pair, it's not to the same degree that you would have in an atom. So you can actually So although this would be our electron domain geometry, it's difficult for us to predict our molecular geometry because we're not certain how the existence of this non-bonding pair is going to affect our geometry. So in this case, we are also uncertain. So you'll notice that the cases where we're uncertain, these are the cases where we have lone pair. This is, in this case, these two cases where we have lone pair electrons. And in this case, it's where we have different kinds of angles. So it's a lot more. So we can't be sure that we have one specific bond angle. We probably have multiple bond angles in this scenario. So that's something to be aware of. The uncertainty comes from the existence of lone pairs and the existence of having different kinds of bonds in your atom. Sorry, in your